Hello and welcome to another ContinuousPrint release video. This is a release for version 2.4.0. I've made a number of visible and invisible changes, and we're going to go over each of those in turn. I also have a sneak peek of some work that's been under development for the last couple of months involving network printing. Without further ado, let's start with the invisible stuff first. At the top of the list, we have a bug fix for ordering sets by rank. I've also improved interactions between ContinuousPrint scripts and original Octoprint scripts. There's also additional documentation on preprocessors. I've tightened integration with Spool Manager so that they perform better together. And finally, I've added Simplify 3D support so printer profiles are recognized for S3D sliced G-code files. The first visible change I wanted to show you was in the draft mode of jobs. In addition to the stats at the bottom of each job, there's also a link here to show and high queue stats. And you can use that to see the total aggregates for each job for whatever you have configured. So right now, I don't have Spool Manager installed in this virtual instance of Octoprint, so the filament amounts aren't shown, but the total time is actually aggregated across the two different jobs here. Next, we have in the settings in ContinuousPrint, under Behavior, there are two new features. The first of which is G-code overrides, which allow you to actually prevent certain G-code lines from executing in your scripts. Now these could be things like cooling down the bed. You may not want those lines to actually execute if you're running continuously in a print queue, because that might slow down turnover as new jobs come in. So you can put lines here. Every line is a new G-code command, and any lines in this text box will be ignored in your original G-code files. Be advised that you can't change this immediately. You have to save the settings and then restart Octoprint for the new G-code lines to be accepted. Taking a look at these other two settings here. So I've actually added support for auto-slicing STL files in your queue. In this case, I'm using Preprint Service. This is another excellent plugin that has been very well designed. It actually uses an external server to automatically orient and turn STL files into G-code files. If we have that set up in Octoprint as well as ContinuousPrint, you can specify it here. You can specify your slicer profile. And when you go to add files to your queue, you may notice now that in addition to G-code files, there's also STL files that have this little plus button. And you can add that into existing jobs. You can create a new job, whatever you want to do. It basically acts the same as an STL in terms of queue behavior. But for instance, if I were to remove all the other things here and just try to print this STL of a lawn chair, and I start managing, you'll see that it will use the slicer to slice the file, and then it will convert that to a G-code, save the G-code file, and then start printing it as a replacement for the STL that it would print otherwise. As you can imagine, this is pretty powerful. You can basically just add STL files in. You can configure your various printers of different kinds, like your Delta printers or Cartesian printers or belt printers, with a slicer that works for them. And regardless of the style or type of printer that you have, if the STLs are passed around on the network, any printer could print any STL file without you having to slice and upload all of the G-code files that you would need for compatibility. So this is a really cool step towards just being able to chuck a model into the network, just have it print out. Now if we go back to ContinuousPrint's settings page and we go to the events section, you might see a couple of new lines here as well. I have added a simulation that will hopefully help with debugging scripts and preprocessors. What it'll do is whenever you change a script, the values of the script, or add scripts to events, or change the preprocessors attached to the scripts, it'll automatically run a simulation of what that would produce in terms of G-code to the printer and in terms of output to the web interface. So if you expand this line here for a simple bed clearing script, for instance, with no preprocessor, it should just be the G-code that you gave it and no notifications or errors, any of that kind of stuff. But if you have, for instance, a notification that you wanted to add to your print, you would actually see that notification here, as well as the contents of the script. In this case, it's just a comment, but it would be whatever the finished value of that script happens to be after the preprocessor has been run. And then if we create a new preprocessor that raises an exception, and we save that, go over to our bed cooldown script and tell it to error, basically, you'll see the exception gets thrown and a default G-code pause command will be run that prevents the printer from doing anything until someone actually takes a look at what's going on. So hopefully with simulations, you should have a lot easier time crafting the scripts that you need to succeed in your print queuing. If you do want to have even more knobs and levers to pull, you can look into the state details of the simulation, and you can mess with the simulation state. So this is what's injected into the preprocessor when it's run. It's just the same style of values that you would see normally, and also what's listed in the docs as well. And if you ever set any values in your preprocessors, those will be placed here under modified state. And now rounding out with a quick preview of networking. This is something that I've been working on for the last couple months, which is why the velocity of releases has dropped as of late. It's going to be a separate plugin, and this plugin is going to also allow for non-local area network printing, so WAN printing as well. The way it's going to do this is through a decentralized library called libp2p, and it'll be able to automatically discover and connect to 3D printers both locally and around the world. The new code is a lot more modular, so it should be a lot more useful for varying use cases in terms of network setups for multiple printers or print farms. For instance, you can use it for small business or small print farm purposes where you have a number of printers on location and they all need to coordinate, but there's not a whole lot of cross-network stuff happening. It's more or less a single location. You can also construct clusters or campuses where several tens of printers could connect to a local fabric, and then they could all be bridged together to support some larger purpose. You could even go a bit more decentralized. You could have a community or a grassroots effort where multiple people belonging to an organization can have printers, and they can sort of print collaboratively regardless of where their printers are and meet up in physical space to exchange parts. Or you could even have more of a vendor model where different locations could source print files to print, and then different destinations or fabs could print those pieces regardless of where they happen to be. So if any of this interests you, if you're interested in trying it out, or if you're interested in just kind of hearing more of what's going on along the way, I will be posting more frequent updates to my Patreon and Ko-fi, and I'll also be collecting potential beta testers in advance of a proper release. With that, that's all I have for today. Please give the changes a try, let me know what you think, and happy printing.